guys. Good morning, guys. Okay, I'm going to pick it up from here. All right. This was what we did yesterday. All right. So I decided to use this place because where I was supposed to use inside the main room is so dark. There's no lights, and sun is not yet out for us to use solar. Okay. All right. So I'm going to start from page 1. So this afternoon we shall be looking at CHM. Coming. It's wet. The board is too wet. This afternoon we shall be looking at CHM 001. So we're going to be considering hydrocarbon. This is strictly chemistry class. For what? For Jamb. For the Jamb, this place is wet. For the Jambitos. Alright. So we have done what's it called, organic chemistry in the we've done organic chemistry in the what's it called, in the physical class. So I decided to do hydrocarbon in the life section. So you know that hydrocarbon, the word hydrocarbon is the companion, or let me just say the combination, the coming together of the hydrogen atom and the carbon atom. Sure, you understand? So hydrocarbons are also organic compounds. You understand? The organic compounds that are made up of what? The hydrogen atom and the what? Carbon atom. Sure you get. But I'm going to give us a basic definition for this that you need to understand. So stay tuned with me. So yeah, I have that hydrocarbon. Hydrocarbon is the simplest organic compounds. Is the simplest organic compounds containing carbon and hydrogen atoms only. So this is the basic definition of hydrocarbon. So I am writing this basically because of the white students. As for Jamb students, just know that hydrocarbons is the simplest organic compound are made up of what? Yeah, carbon atom and the hydrogen atom. No stress. Okay. So we shall be looking at the types of hydrocarbon. Then we also have the aliphatic. Then we also have the aliphatic, aliphatic hydrocarbon. Please drop a comment in the comment section if you are following this class. Okay, guys. All right. All right. So now, moving on, I've talked about hydrocarbon. I said hydrocarbon is the simplest organic compound containing carbon and hydrogen atom only. And I said types of hydrocarbon. We have the saturated hydrocarbon, we have the unsaturated hydrocarbon, we have the aromatic hydrocarbon, and we have the aliphatic hydrocarbon. So take note of these four basic types of hydrocarbon. So I shall be looking into individual, I shall be looking at individually, look into it one after the other so you can get the main concepts. All right. So moving on, clean this guy. All right. So don't forget the topic is still um, hydrocarbon. All right. So looking at, we've discussed the types of hydrocarbon. So I'm going to take a look at saturated hydrocarbon. So saturated hydrocarbon. Now, all these saturated, what are saturated hydrocarbons? Saturated hydrocarbons, they are what? They are organic compound containing only carbon uh, and hydrogen atoms in which there exists a single bond between two adjacent carbon atoms in the carbon chain. Again, I repeat, if you write in, I said saturated hydrocarbons, the organic compounds containing only carbon and hydrogen atoms in which there exists a bond, like this, a single bond between two adjacent carbon atoms in the carbon chain. So for instance, the alkane family. So when you talk about the saturated hydrocarbon, under the saturated hydrocarbon, we have the alkanes family. We have only the alkanes family, and the reason why we have this as a saturated hydrocarbon is because of the single bond between them. Like for instance, you know that the formula, that the general formula for alkane, the molecular formula for alkane family is CnH2n plus 2. Alright, so let's suppose that n is equals to 1. So we want to see what it's going to give us. That will be CH into 2 into 1 plus 2 is equals to what? CH2 plus 2, which implies that what we have what? CH4. So this CH4 literally, you know that it is representing what? Methane. Okay, so every family of alkane end with ANE. A. Are we together? Every family of alkane end with ANA. And looking at this now, we have been able to derive methane, and the structure for methane is simply, we have how many carbon here? Just one carbon. Let's see, let's produce the hydrogen bounded by it. So we have H, and we have H, and we have H, and we have H. You can see that everything is just a single bond. Alright, it's just a single bond. Now, moving on, let's see if whenever whenever n equals to 2, what shall we have? We shall have what? C2. From this formula, we are using this formula to deduce what n when n equals to 2. So C2, then H2 into 2 plus 2. Then we are having what? C2 H4 plus 2. At the end of the day, we are having C2 H6. So this H6, let us look at the structure we are going to get from this. So we should be, how many carbon are we having? CC, carbon to carbon. So let's produce our hydrogen around it. Alright, we have this. You can see a single bond, a single bond, a single bond, and a single bond. You can't find anything like double bond. This is what we call double bond. You understand? Double bond can occur like this. So when you have double bond, it's not more saturated, it becomes unsaturated. Like all those unsaturated used to have double and triple bond. But saturated hydrocarbon just have only one bond. And the kind of bond that exists between a saturated hydrocarbon is what we call single covalent bond. Note it down. The kind of bond that exists between the carbon atoms of what's it called, saturated hydrocarbon is called a single covalent bond because they are not reactive, they are less reactive. They are not reactive at all, and they are the kind of organic compound. This alkane family, they are the kind of organic compound that um I was going to remember some. They are the kind of compound that does not have any functional group. They have no functional group. They are just there. You understand? So that's it. And what's it called? Literally, they can have isomers. Yes, they can have, but they don't have a functional group. So that's it. So now I shall be looking at what's it called? I shall be looking at the unsaturated hydrocarbon. Don't forget I said alkane family are saturated hydrocarbons. So when we now talk about the unsaturated hydrocarbons, unsaturated hydrocarbons. So write, if you are writing, I will dictate. Now what are unsaturated hydrocarbons? I'm giving you the explanation of unsaturated. They have double and triple bond. But saturated hydrocarbon, they have just single bond. They are weak. So now unsaturated hydrocarbon, these are organic compounds. These are organic compounds containing only carbon and hydrogen atoms in which there exists a double or triple bond between two adjacent carbon atoms in the carbon chain. So I repeat again, these are organic compounds containing only carbon and hydrogen atoms in which there exists a double or triple bond between the adjacent carbon atom in the carbon chain. So for example, I've said, like I said earlier, both family or members of alkane or alkyne, they are unsaturated hydrocarbons. Sure, you understand? So alkane and alkyne, they are both unsaturated hydrocarbons. Then you all know that the formula for what's it called? CnH2n is simply the general formula for the alkene family. That's the in family, that's the alkene family. But when you have CnH2n minus 2, this one belongs to the in family, that's alkyne family. Alright, so in this place, this one produce double bond, and in this family, they produce triple bond. Okay, so this one, they are examples of unsaturated hydrocarbon. You understand? But a situation whereby something like this is having, okay, CnH2n, you know, this one is having just a single bond, this alkene family. So something like this is what we call our saturated hydrocarbon. So you can get the difference from here. The difference is very clear if you are following. Okay. All right. So I continue. So now moving on, I shall be talking about aromatic hydrocarbon. Aromatic hydrocarbon. Aromatic hydrocarbon. Now I proceed under aromatic hydrocarbon. So these are organic compound in which the carbon atoms are joined together to form a ring. Okay, the organic compound in which the carbon atoms are joined together to form a ring containing alternating ring and double bonds, e.g. aromatic benzene. So aromatic benzene is a typical example of aromatic hydrocarbon. For instance, this is your benzene. So we have benzene, normal. So you draw it like this. This is your aromatic benzene. This is aromatic benzene. You dash it like this. Then in this place we have a double bond, and in this place we have a double bond. Okay, so you can now have just this, the hydrogen around it. All right. Now this comes this way. This comes this way. This one comes this way. It's running this way. So we have hydrogen here, hydrogen here, hydrogen, 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 hydrogen. Okay, so this is a typical example of aromatic hydrocarbon. So this is the structure of benzene. All right, so we shall be moving on to aliphatic hydrocarbon. Aliphatic hydrocarbon. Aliphatic hydrocarbon. All right, aliphatic hydrocarbon. Maybe I will drop the PDF notes of this course in my community, so you can check from the community after the class. So what are aliphatic hydrocarbons? They are organic compounds such as alkane, alkynes, and cycloalkanes. You understand? So the set of organic compounds, alkanes, alkene, alkynes, and cycloalkanes. All these are referred to as aliphatic S hydrocarbon. Excluding what do you notice that is not there? Excluding what? Excluding what? Look for it. Alright. So these are the member of aliphatic hydrocarbon. So let's move on to what's it called? Classification of hydrocarbons. Classifications of hydrocarbon. Classification of hydrocarbon. Classification of hydrocarbon. Classification of hydrocarbon. Alright, so under the classification of hydrocarbon, we have the alkane. Alright, so take note of this part. Alkene. Then we have the alkynes, and we have the benzene. So how many classifications do we have? We have just 4 classification. 4 classification of hydrocarbon. How many classifications do we have? We have just 4. We have the alkene, alkyl, and benzene. So those are the 4 classifications. So moving on, we shall be talking about alkene. How do you define alkene? No one will ask you in Jamb to define, but there are sometimes that they can pick question from just that definition. So you need to know the definition of alkene. Now I proceed this way. What are alkenes? Alkenes are straight or branched chain hydrocarbon, or you can say alkene are saturated organic compound, anyone you choose, in which all the adjacent carbon atoms in the molecules alkenes are joined by single bond. Are joined by what? Single bond. Now I've told you earlier on that the general formula for alkane is what? CnH2n plus 2. Don't forget. So I want you to note this down. I'll be telling you some things you have to note down. Note, alkane has no functional group. I've said that before. And why you see that alkane has reason is because that they are saturated hydrocarbon containing only carbon to carbon and carbon hydrogen single bonds, making them very unreactive, which means that alkane family are very, very unreactive because of that single bond. Alright, and don't forget that in the last class we defined that a functional group is an atom or group of atoms common to members of homologous series, which determines the chemical properties of the series. Don't forget in our last class. So now examples of alkane. So under the examples of alkanes, we have the methane, we have the ethane, we have the propane, and we have the butane, we have the pentane, we have the hexane, we have the ethane, we have the octane, okay, we have the nonane from the word nonane, and we have the decane. Okay, so for the methane, methane is when n equals to 1. When n equals to 1, this one becomes, using this formula. What is the formula for alkane family? All these are examples of alkane. So alkane family is CnH2n plus 2. So when n is 1, this one becomes CH4. When n is 1, what happens? That will be C2H2, that will be C2H6, I think. Yes. So and when n is equals to 3, and this one becomes C3H8. So you can further continue the molecular formula for the rest since you know the formula of alkane. So now, for instance, let us consider the structure of methane and ethane and pentane. So let's consider those structures. So to save us time, So you do the remaining structure yourself. I've given the examples. For instance, methane, you know that methane is CH4. That's this, and H, and H, and H. Now, this is for methane, okay? But when you talk about the ethane, ethane is having two. That's ethane is um, C2, ethane is C2H6. We use that formula to derive it. And having this, that's H, hydrogen, hydrogen, and hydrogen. How many hydrogen? One, two, three, four, five, six. Two carbon. You can see it's completely what we have there. But if you don't want to write the formula like this, you can write it like this. You pick from this first one like this, then you have CH3, that is 3 hydrogen. Then you move to the next part of the chain, dot, then you have CH what? 3 as well. You understand? Alright, so that's it. So another one, moving on, we have propane. Propane is when n equals to 3. Let's see what is given. That means we should be having 3 carbon when n equals to 3. When n equals to 4, we should be having 4 carbon. And this one gives us this. This one gives us this. Then hydrogen, 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 then hydrogen, then hydrogen, then hydrogen, then hydrogen. Let's count. We have 3C, that's C3. Then how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. Having 8 hydrogen. So if you don't want to write it this way, you can also write it this way. P from the first, you have CH what? 3 dot. P from the middle, CH what? 2 dot. Then P from the last, CH what? 3. So it's either you write it this way or this way. Either of the two ways are perfectly okay. Okay? So all right. So I shall proceed further to the next part of it. So this is okay. Don't forget this is methane, this is ethane, and this is propane. Propane. If you have been following, you should be able to jot something reasonable down. All right. So I shall be cleaning this guy now. All right. Okay. And there are some things that we call what's it called? They are not normal alkane. You understand? They are not normal alkane. Okay. Now let's consider some examples. All right, so they are not normal alkanes. So and those kind of structure that they are not normal alkanes, when we did those examples, they are called condensed formula. So there are some condensed formula that they are not what's it called? Not all alkanes are real alkanes. So there are those abnormal alkanes, they are condensed formula. For instance, suggest I have something like this. This is also alkane as long as it's having single bond. It is also alkane. Anything that's having single bond belongs to alkane family, regardless of the kind of way structure it is being drawn. But we have the normal alkane and we have the condensed alkane. That's the condensed formula. So this form is a form of the condensed form. Okay, then we have H and H. Then we have H, hydrogen here and hydrogen here, hydrogen here and hydrogen, hydrogen and hydrogen here. Okay, so now look at this kind of. I'm still going to talk about nomenclature though, but I just want to glance through this. So look at this type now. But note in chemistry, CH3 is what? Is methyl. The name for CH3 is methyl. That like something like having 3 hydrogen. See 1, 2, 3, 3 hydrogen, right? Now, how do we name this compound? But this one is branched. This is a branched alkane, and branched alkane are what I told you that they are abnormal alkane. So branched alkane are condensed formula. They form a condensed formula. That's branched alkane. So the condensed formula is different from the normal. Normally we will call, if know that it is condensed, looking at this, if I remove this nonsense away, it is propane. But if you see that something else should be added to propane, because if I remove this one away, it's by your by, you are left with propane, and I'll pour hydrogen here. You understand? Because propane is having 3 carbon, but since you have added something, it becomes a condensed propane. Yeah, condensed formula of propane. So how do we call this? Literally, we are going to start with, according to the nomenclature, you count from the below like this to check which one is the longest chain. 1, 2, 3. You count from the top again. 1, 2, 3. Look at that side, the longest side of that branch chain. This is the branch chain. Which one is, what's the number of the longest side of that branch chain? Because the longest side, the both sides are equal. 1, 2, 3. Of that branch chain, we have 2. One, two, three. On that branch again, you have two. I may have like two or three. We'll be able to reduce the longest one. So now it is two. That means we start with two. So it will pick the number from the branch chain. So the branch chain is called what? Methyl. So what's now the formula without the branch chain? What's the molecular formula of this structure without the branch chain? Methyl what? Propane, because it has a single bond, so it's propane, not propane. If it's propane, that means having double bond. If it's propine, it's having triple bond. So this propane. So this is 2-methyl what? Propane. So this is a condensed formula now. Understand? It is no more in the normal formula that we know it to be propane. Understand? So that's that by the way. Alright, so how do you now write something like this? If you don't want to write it out, literally propane is just C3H H, let's see, okay, am I correct? C3H8. If I'm not for CN H2N plus 2, okay, 3, 6, 7, 8, okay, it's C3H8. But this is for normal formula for propane. But as it is like this, the way we can rewrite this, because it is condensed, it becomes the first one here is what? CH3 dot. And the middle one, we cannot pick it together like this. So we have to first deal with, before it's under this one that we have the branch name, but let us pick the one that is unbranched from the branch thing. So this one here is CH, okay, CH, abi. Then you can now, I think, yes, I think we are getting along. CH3, so CH come first, sorry. I think there's an error. CH, then you can now have CH3 because of this one. This one that is branch will be inside the bracket, then CH3. So it is correct this way, okay? It's very, very correct. It is necessary to always put this point too. Yes, it's necessary. Alright, let's move on to the next one. Nomenclature of alkanes. We're almost done with the class. Nomenclature of alkane. Nomenclature. Now, if you're writing, but I told you that nomenclature is a way of naming different isomers of organic compounds. So now, let's talk about the nomenclature of alkane. The first nomenclature is that they said for normal straight chain like alkanes, the first four members are given names related to their history, while the rest from the fifth member, Latin or Greek prefixes are used indicating the number of carbon atoms in the chain. That's number one. Secondly, for branch chain alkanes, the longest chain is determined, that is, the chain containing the greatest members of carbon atom. This is regarded as the parent hydrocarbon. Pick those points now. And the carbon is named as derivative of the parent hydrocarbon. And thirdly, is it that the chain is then numbered from the left or right, and from right to left to locate the position of the side chains. Then the direction chosen is that which gives the side chain the lower number. So it's just three nomenclature we have. So that is the instruction you should follow when you want to name or whatever it is called. So I've done this, we don't have time. So now let's move to reaction of alkanes. Reactions of alkane. I'm going to stop at combustion and I give us assignments. Reactions of alkane. I've talked about that before, I've explained it, but let me just give you a note on it of alkanes. Now, moving on to the reactions of alkane. Now, jot down. Alkanes are all reactive. They are what? They are all reactive under normal condition of temperature and pressure. Alkanes are all reactive under normal condition of temperature and pressure. Now, the types of reaction alkane will undergo, you need to know that. So the type of reaction alkane will undergo under special condition is what we call substitution reaction. Now, which type of reaction does alkane undergoes under special condition? It is called what? Substitution reaction. What is substitution reaction? This is a reaction in which more hydrogen atoms of alkane are substituted for a more reactive atom or group of atoms. Okay. Now let's move on to combustions of alkane. Then we round up. Now, when you talk about combustion of alkane, that's a subtopic. Alkanes burn in air or oxygen to form carbon 4 oxide and steam or water. Now, the reaction of alkane is largely exothermic. You all know that. If you go back to the exothermic reaction, we've done that in the physical class with evolution of very large amounts of heat energy, with very large amount of heat energy. And I want you to note this down, that paraffin wax are used in the manufacture of candles. So you should know what they use to manufacture candle now with what I said. Now, what is the equation for the combustion? Anytime you have sulfur for combustion, what is the equation? We are going to do a few examples. Now, combustion equation is given as, for alkene, combustion equation is given as CnH CnH2n. The formula comes first, plus what? Plus 3n plus 1 over 2 O2 to give NCO2 plus n plus 1 H2O plus heat. So this is the combustion equation. The combustion equation, CE, combustion equation. This is formula for equation in chemistry. Now, suppose I ask you to find the combustion formula for butane. For instance, for butane now, I say you find the combustion equation. You know that for butane, it's N equals to 4. It's the fourth, what's it called? It's the fourth member of the alkane family. So imagine I say you find the combustion formula for butane. That will be using this formula. That will be C4H2 into 4 plus 2 plus into 3 into 4 plus 1 over 2. Right? This O2 then give 4 CO2 plus 4 plus 1 H2O plus heat. Right? You can put heat to represent that. Then we have what? C4H what? This one is 6, 8, right? 8 plus this one is 12, 13. So this one becomes 13 over 2 O2, right? So give us 4 CO2 plus what? Plus 5 H2O, 5 molecules of water plus heat. So this is the combustion equation for butane. So on your own, give me the combustion equation for pentane, for octane, for nonane. So give me the combustion equation and drop it in the comment section. And for the WIAC students, I want you to give me, I have assignments for you. For the WIAC students, I want you to give me the preparation of methane gas in details. This is for the WIAC students if you are watching. And list 3 uses of methane. This is an assignment for you. Okay, but before I round up this class, I'd like to talk about preparation of alkane. You can use that preparation of alkane to solve this problem. Now, I have that alkenes are prepared by heating mixture of sodium salt, of alkanol acid, and soda lime. This reaction is called decarboxylation. Okay, decarboxylation, decarboxylation. This is the spelling. Soda lime is a mixture of solid sodium hydroxide and calcium oxide. Then sodium hydroxide is a deliquescent solid, and while calcium oxide is hygroscopic. So calcium oxide is therefore mixed with sodium hydroxide to keep it dry. So let's look at some organic compounds. Let's look at them. Let's look at some organic compounds. So I want you to drop the name for me in the comment section. Drop the name for me. Go and make your research. We have this. So you drop the name in the comment section. This. So you give me what the name is. Give me the name of this. Give me the name of this. Drop it in the comment section. For the Jamb students only. This question 1. This is only for the Jamb students. going to give me the name of this compound. Okay, you are going to give me the name of this. I have this. Give me the name of this compound. Only for the Jamb students, the name of this compound. Follow the instruction of the investigation and drop your answer in the comment section. Drop your answer in the comment section. Give me the name of this compound. So don't forget, you can message me on 070-5967-6430 to join our WhatsApp online class. WhatsApp online class. So this is my WhatsApp number. So the country code is +234 to represent this zero. Alright, so thank you for watching. Thank you. I hope you have learned a lot from this. So God bless you. Keep watching, subscribe to our channel, recommend this channel to your friends. I shall be doing math video for the Jambite in the evening. So or in 2 hours time I shall be coming for mathematics class. Thank you. Bye.